Hello, welcome back to LK Tuition. My name's Lucas and today we're going to be looking at compound interest and depreciation. Hope you're well and let's get started. Alright, so first of all, what is interest and what is depreciation? Well, interest is when an amount increases. So like you put money in the bank, your interest adds to it, doesn't it? You get a little bit of interest, a little bit of extra money and your bank account will increase in value. Whereas depreciation is when an amount decreases. So for example, you might buy a brand new phone, it costs a certain amount of money, but after a year it's not going to be worth as much because it's going to be a little bit older, and each year it's going to become less and less valuable. Now the word compound means that the interest or depreciation isn't the same for following years. So there's been a previous video on simple interest, when you get a certain percent of interest in the first year and it's exactly the same every year. But compound interest takes into account the new amount every year when you get the interest. So for example, if I invested £100 into a bank with 5% compound interest, in the first year I would get £5 interest because £5 is 5% of 100. Now if this was simple interest, I'd just get £5 every year. It'd just be based on that original amount. But because it's compound interest, in the second year I'm going to get 5% of the new total, £105. So I'd get a little bit more interest. I'd get £5.25 like it says here. Okay, so compound interest is going to change all the time, but there's an easy way of working it out over a certain amount of years. So we can use powers to easily work out compound interest or depreciation over a certain number of years. So what you do is you first find your multiplier like you would for simple interest, so check out that video for that. You find your multiplier and then whatever your amount is, you times it by the multiplier, but that multiplier is going to be to the power of however many years you're investing for. So for example, if we save £2,000 for 3 years with a compound interest rate of 4%, the total amount after 3 years would be, to the nearest penny, I've rounded it up, so it'd be 2,000 times 1.04, so that's the 4% added on. That's your multiplier, 1.04. But because it's 3 years, let's use a different colour for that. Because it's 3 years, it's to the power of 3. So that's where those numbers are coming from. And I've just stuck all that into my calculator and I've ended up with this. £2,249.73. So you find your multiplier, you find out how many years it's going to be, and that's your power, and then just times the amount by that, and that's going to give you the amount after that many years. Okay, so here are some examples. Feel free to pause the video and have a go. These are all interest questions, so they're all going to be going up, but otherwise we'll do them together. But remember, this is a calculator one, so don't be trying to do these in your head. Alright, so number one, £6,500 is invested in a bank with compound interest of 2% per year. How much will be in that bank account after 4 years? Okay, so this is going to be let's use a pen. So this is going to be, rather than a highlighter, so 6,000, that's a bit messy. So it's going to be 6,500 times, well, what's my multiplier? Well, the interest is 2%, so 0.02. And that's going to be added to our 1 whole. So this is 1.02 and it's for 4 years, so it's to the power of 4. So let's do that in the calculator. So 6,500 times 1.02 to the power of 4, and we end up with £7,035.81 to the nearest penny. Okay, and just make sure, having a look at this kind of logically will help you to realize if you've made a mistake. If I'm going to be getting interest, it makes sense that this is going to be going up. Yeah, so it makes sense that that is going to be a higher number. Okay, number two, £600 is invested for 2 years at 10% per year compound interest. How much interest will be earned in those 2 years? Okay, so let's just be a little bit careful now. So it says how much interest will be earned in those 2 years. So not what will be in the account, but how much interest will be earned. So let's just do what we normally do. So 600, the multiplier, so it's 10%, so that's 0.1. So the multiplier is going to be 1.1. and it's for 2 years, so to the power 2. So 600 times 1.1 to the power of 2 is 726. Now that is the new amount in the account, but they're asking us how much interest will be earned. So to work out the interest, we would just want to do 726, take away the original amount, and that is £126 interest. Okay, so that's how much extra money is there in the account. All right, number 3, we've got that £5,200 is invested at 2.8% compound interest per annum. How many years will it take for the investment to exceed £7,000? Okay, so this time we can't really use our formula, but we want to basically use that multiplier again and again until we reach 7,000. So I've not given myself a lot of room, but let's just do the first year. So 5,200 times, now the multiplier is going to be 1.028. So 5,200 times 1.028, and that gives 5345.6. And now that we want to times that by 1.028. So this was, let's just circle it, that was year 1. And then we want to do 5345.6 times 1.028. And that's going to give us what it is in year 2. So times 1.028. And that gives us 5495.28. And that's year 2. Now we keep going and we're going to count how many years it's going to take to get to 7,000. So on my calculator, I've actually got now answer times 1.028, and I can just keep pressing the equal sign, and that's going to give me the new amount per year. So we'll actually try and do it on the screen. So that's year 2, then I press equals, that's year 3, year 4, year 5, 6, 7, 8, 9, 10, 11. Okay, and after 11 years it's going to get over £7,000. so let's just write that down. So I'll do a few dots. So dot 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 dot. That doesn't look very good, but then so we've got so we'll just write 5,200 times 1.028 to the power of 11 is more than 7,000. So it's going to take 11 years. Okay, so I've not really written that as much as well as I would have liked, but I kind of ran out of space. So there I've just used a more than symbol there. Okay. All right then. So let's now have a go at a few depreciation questions. Again, feel free to pause the video and try it yourself. Otherwise, we'll just do it together. Okay, so a car was bought for £18,000 and its value depreciates by 15% each year for the first 3 years. What will its value be after the 3 years? Okay, so we start with 18,000 and we times it by, now it's a 15% decrease. So 15% is 0.15. Take that away from 1, we're going to get 0.85. So our multiplier is 0.85. And because it's 3 years, it's going to be to the power of 3. Then we just type that into our calculator. So 18,000 times 0.85 to the power of 3. And that is, so we'll put it in pounds, £11,054.25p. So that's gone down quite a lot in 3 years. Right, number 5. The value of a £600 television decreases by 8% every 4 months. What will the value of the television be after a year? Okay, so here we've got £600. What's the multiplier? Well, 8% is 0.08, and so 1 minus 0.08 is 0.92. Now, what is the power? Now, it decreases by that every 4 months. What will the value of the television be after a year? Well, a year is 12 months, which is 3 lots of 4 months. So I hope that makes sense, that this would then be to the power of 3, because it's depreciating every 4 months. 4, 8, 12, that's a year, so it's depreciated 3 times. So that's why that power is 3. So we've got 600 times 0.92 to the power of 3, and we're going to end up with £467.21 to the nearest p. Alright then, so, and again, does it make sense? Is your number going down? If it depreciates, it should be a lower number. Alright, it's just a couple of worded examples to finish off. So Sally bought a piano for £3,200. Each year, the value of the piano increases by 11% of its value the year before. What is the value of the piano after 2 years? And how many years would it take for the value of the piano to be at least £5,000? Okay, so there's a few things being asked here. So let's do the first part. What is the value of the piano after 2 years? Well, it's going to be 3,200. The multiplier, because it's 11%, it's going to be 1.11. And it's 2 years, so the power is 2. So this is 3,200 times 1.11 to the power 2, and that gives us £3,942.72. So that's the first part of the question. Now we want to find out how long will it take for it to get to £5,000. Well, we've done 2 years, so let's times that answer again by 1.11, and that's going to be our answer after, sorry, the lighting's not very good, after 3 years. So if I press equals, that's 3 years, again, that's 4 years, and again, that's 5 years, and that's over £5,000. So let's just write that down then. So 3,200 times 1.11 to the power of 5 equals 5392.19, which is more than 5,000. So that means, that's just a little arrow, it will take 5 years. All right then, and let's finally finish off with one more question. So this says that when a tennis ball is dropped, it bounces and rises to 60% of its original height from when it was dropped. The ball is dropped from a height of 2 meters. Calculate the height of the rise after the first bounce. Well, this is going to be 2 times, well, it actually tells you it rises to 60% of the height from which it was dropped. So we can actually just put 2 times 0.6, and that's going to be 1.2, and it's in meters. So after the first bounce is 1.2 meters. Part B says calculate the height of the rise after the second bounce. So we're on 1.2 for the first bounce, and then we times by 0.6, and let's do it in the calculator. So 1.2 times 0.6, we end up with 0.72 meters. Okay, and then it says for how many bounces will it rise to at least 20 centimeters above the ground? So it's already done 2 bounces, it's still 20 centimeters above because it was, well, 72 centimeters. So let's keep going to figure out what we get. So let's times by 0.6 again, and we'll write down what we do. So 3 bounces. So I'll just write that as 3, let's do 3 bounces is 0.432. We do it again for 4 bounces. So 4 bounces is 0.2592 meters, and then 5 bounces is 0.15552 meters. So for how many bounces will it rise to at least 20? Well, this 5th bounce is under that, isn't it? So that is no good to us. So it will be 4 bounces. So I'll just square that off as the answer. All right then, so hope you found this useful. This has been LK Tuition, and don't forget to like and subscribe. I'll see you soon for some more maths videos.